Equation of plane. Started that? Okay, right. So equation of plane. The first thing is equation of plane under the condition, okay, normal and perpendicular distance to the plane. Perpendicular distance from horizon to plane. Perpendicular distance from horizon to plane. Okay, this is D, and normal is n cap. When both are given, okay, normal vector to the plane and the perpendicular distance from horizon to plane. When these two are given under this, okay, right, the equation of plane is, vector equation is, okay, r bar dot n cap equal to d. Okay, na? Right? Its Cartesian form is Cartesian equation. Cartesian equation is, okay, Lx plus my plus nz equal to d. So under first condition, so these are the equations, vector equation and Cartesian equation. So when normal to plane, that is perpendicular vector to plane, and the distance from horizon to plane, perpendicular distance or distance from horizon to plane. When these two are given, the equation of the plane is this. This is vector equation. This is Cartesian equation. This is all over. Next thing is, okay, second equation. Second is a single point, a point on plane, a point on the plane with positional vector a bar of Cartesian form x1, y1, z1. Okay, when a single point on the plane and normal vector are having a direction perpendicular to plane. Perpendicular to plane. That is called indirectly normal vector. So normal vector n bar are given. Okay. So when these two are given here also, under these two, this is the equation. When a point and a normal vector are given, the equation of the plane is, vector equation is r bar minus a bar dot n bar equal to 0. This is the vector equation. Next, the Cartesian equation is, that is Cartesian form of the same plane under the same conditions. Okay, that is L. We are taking ABC. A into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. What are ABC? ABC are direction ratios of n bar. Therefore, we can write n bar is taken like this: AI, Bj, Ck. Okay, what is A bar? See, this x1, y1, z1, the fixed point, that is fixed point. A bar is, see, this is the fixed point. Okay, fixed point, direction, this is fixed point, positional vector of a fixed point. So these are the
direction ratios of A.
Direction ratios are coordinates. Coordinates of that point. So these two are over. Next, one more thing is also over, that is equation of plane passing through three non-collinear points. Three non-collinear points. So next, three non-collinear points are given. Three non-collinear points. Right. Non-collinear. Three non-collinear points are given. Okay. Under these three non-collinear points, see A, B, C, A bar, B bar, C bar are the position vector of three non-collinear points. Then R bar minus, okay, A bar dot B bar minus A bar cross C bar minus A bar, this equal to 0. Where A bar is the first point position vector, B bar is second point position vector, C bar is third point position vector. Okay. Next, this is vector form. This is vector equation. Next, so Cartesian equation for this is what is the Cartesian equation? How to say Cartesian equation? So this is the triple product. Triple product. So therefore we can write Cartesian equation is x minus x1 in these coordinates, y minus y1, z minus z1. So second point minus first point, that is x2 minus x1, y2 minus y1, z2 minus z1. Okay. X3 minus x1, y3 minus y1, z3 minus z1. This was equal to 0. So this is, so these 3 points over. Okay. Revision also completed. 3 points. Next, that new point is equation of a plane. Okay. Equation of a plane under which conditions? Huh? No. Yeah? Equation of the plane. Okay. So whose intercepts on x, y, z axis are given. Whose intercepts, that is intercept form. Whose intercepts on x, y, z axis are given. Okay. So this also called intercept form. This is also called intercept form of plane. Intercept form of plane. Okay, right. Intercept form of plane. Suppose x-intercept, y-intercept and z-intercept, all three are given. See, x-intercept is A. X-intercept is A. Y-intercept B. Z-intercept C. Then equation of plane is x by A, or we write in small letters, intercepts. Okay. X by A plus y by B z by C equal to 1. This is the intercept form. See, okay. How it is obtained? Okay, right. See, x-axis, y, z. Right. See, this is z-axis. Okay, x-axis, y-axis, this is z-axis. Suppose a plane is this. This is intersecting, see, z-axis Z intercept is small c. So that means this length is small c. Okay, this plane is intersecting this x-axis at this point. Okay, see, listen here. Just look at C. Okay, so here this is intersecting x-axis at A, intersecting this y-axis at B, and z-axis at C. Z-axis at C. So the plane is C. This is C. So plane is passing through like this. Okay. Now, how to get this equation? General equation of the plane. General equation of the plane. Okay. General equation. General equation of the plane is. General equation of the plane is. See, ax plus by plus cz. Okay. Plus b equal to 0. Okay. What are ABC? ABC are direction ratios of normal to the plane. Normal to the plane. Ax plus by plus cz equal to plus d equal to 0. ABC are direction ratios of normal to the plane. Right. So this plane is intersecting x-axis. Y-axis, Z-axis, okay. What are the coordinates of this point? So this intercept is A. Okay. So A 0 0. That means intercept means this length is A from here to here. So this length is B. So therefore coordinates of this. Okay. So right. So 0 0 C. Okay. See, this is the general equation of plane. That means this is the equation of any plane. Okay. So right. So this plane is passing through point A. Passing through point A. That means this point must satisfy this plane. Okay. So now substitute. In place of x is equal to a, y is equal to 0, z equal to 0. What we get? See, substitute. In place of x, so 0, this 0 plus d equal to 0. So capital A equal to minus d by a. Okay, right. Next. So since this plane is also passing through this point, substitute in that. From this x0, y equal to bb plus this 0 plus d equal to 0. From this capital B equal to minus d by d. Next, this plane is passing through the point, this point, substitute. X0, Y0, Z equal to C. Right. So 0 plus, okay, Z equal to C. Capital C, small c plus D equal to 0. So capital C equal to minus D by C. Okay. Substitute in this equation, general equation. Okay. This is general equation already written. Substitute in general equation. What we get from that? What is A value? Minus D by A. Minus D by A. Okay. X. What is B value? Minus D by B. Y. Minus D by C. Z. Okay. Equal to minus D. If you write like this. Okay. Take D common, we cancel, and minus also cancel. So finally we get X by A, Y by B, Z by C equal to 1. So this is the equation of plane where A, B, C are the intercepts of the plane. Intercepts of the plane. Right. Next is fifth point. Last equation, right. A plane passing through the intersection of two planes. So, equation of plane passing through the intersection of two other planes. Intersection of two planes. Okay, two planes denoted by pi 1 is first plane, pi 1 is the first plane, that is denoted by plane. Okay, right, we denote it, pi 1 is the first plane, that equation r bar dot n1 bar equal to d1, n1 cap equal to d1, and the second plane equation is r bar, okay, dot n2 cap is equal to d2. So now we have to find the equation of plane passing through the intersection of these two planes. Okay, this is the final condition for the equation of plane, right. This is one plane. We can consider this page is one plane. So this is one plane. This is another plane. Okay, right. So this is one plane. This one. What is this? This is also a plane. This is also a plane. Okay, but this is passing through the intersection of these two planes. Okay, so this is one plane and this is another plane. This plane is intersection of two planes. That means what? See, two planes are intersecting along a line. These two planes are intersecting along a line. That new plane is passing through this line. Okay, that is right. So this can be written as the first plane is r bar dot n1 cap equal to d1. This is the equation of first plane, denote pi 1. Second plane is this equation is n2 cap equal to d2. Okay, these are vector equations. Next, the equation of plane passing through the intersection of these two. Equation of plane passing through the intersection of two planes, two given planes is first plane plus some lambda into second plane. First plane plus lambda into second plane. Implies what is this? The first plane r bar n1 plus lambda into n2 cap is equal to delta d1 plus lambda into d2. We are clubbing these two. Okay, r bar is we are writing only one time because the general point. It's a general point. General point is always represented by r bar or xyz. So this is the equation of single plane. So therefore we have to take only r bar. R bar dot see n1 bar plus lambda into n2 bar equal to d1 plus lambda into d2. This gives equation of plane passing through the intersection of two planes. But intersection of two planes, there are many planes will go under the intersection of two planes. See, this is one plane, this is another plane. Through the intersection of many planes are there. This is one plane, this is another plane, this is another plane, this is another plane. There are many planes are there. But which plane this? So to get the particular plane, one condition must be given. Okay, to find a particular plane, A condition must be given. By using that condition, we can find lambda. Lambda is there. For different values of lambda, okay, this equation gives different equations of planes. Okay, not different equations, that is the equation of different planes. Different values, it gives different planes. Okay, if we take lambda equal to 1, this gives one plane. Lambda equal to 2, it gives another plane. Okay, so what plane we require? Okay, so some condition must be given. By using that condition, we can find lambda. After finding lambda, we replace in this equation. So then we can get required plane equation. Okay, right. This is one.
Sir, N1
right.
cap, N2 cap, sir.
Yeah, unit vectors, because these are unit vectors. Right. Okay, right. Next, Cartesian form, because these two are given in vector form. If plane equations are given in Cartesian form, then how to write? So, A x1, P y1, okay, C ax, we take ax, a1, because, okay, z plus d1 equal to 0. This is the equation of first plane. Okay. Next, second plane equation. A to x, B to y plus C to z equal to D2 equal to 0. This is the equation of second plane. Okay, right. So A1x from this B1y plus C1z equal to minus D1. Minus D1. Minus D1 we can replace some capital D1. Okay? Where D1 equal to minus D1. And then constant, this is also a constant. Right? Next, second equation is B1y C1z equal to some D2. D2 minus D2 is plus D2. Capital D2. In place of that, we are writing C capital D2 equal to minus D2. Right. So B1, B2. Right. Second equation. Next, we are clubbing these. See, x comma a1 plus lambda a2 plus b plus y b1 plus lambda b2 plus c right x y z. So c1 plus lambda c2 equal to d1 plus lambda d2. So this is the equation of plane passing through the intersection of two planes. Okay, that is Cartesian form. So how to club these two equations? This is important. This equation plus lambda into this equation.